All right, we're going to use reference angles to be able to evaluate the trigonometric functions. The values of the trigonometric functions of a given angle are the same values as its reference angle. So the trig functions for the given angle are the same as the reference angle, except possibly for the sign. So sign means it could be a positive number or it could be a negative number. So for an example, the tangent of 120 degrees, its reference angle is 60 degrees, but it's going to give you a negative square root of 3. So let's go ahead and look at the procedures. A procedure for using the reference angle in order to find the trig functions is you first want to find the reference angle and then use that quadrant to find the appropriate sign, if it's positive or negative. So here we go. Example 7. Use reference angles to find the exact value of each of the trigonometric functions. So let's go ahead and find 135 degrees first. So I'm just going to graph this angle theta, which is 135 degrees. Now we're going to find the reference angle. So it starts on the x-axis and works its way up to that terminal side. So that's theta prime. Theta prime is found by taking 180 degrees minus 135 degrees, or simplified, 45 degrees. So that is the distance here. Now, there are special angles that we worked with. If we can memorize 45 degrees has the ordered pair, square root of 2 over 2, square root of 2 over 2. Remember, this is your cosine of 45 degrees, and this is your sine of 45 degrees. So we're working with the sine value, which is the square root of 2 over 2. But in quadrant 2, over here, would also be a positive square root of 2 over 2. So the sine of 135 degrees is square root of 2 over 2, which is same as the sine of 45 degrees. Its reference angle, square root of 2 over 2. Cotangent of negative pi over 3. So let's work with negative pi over 3. If we graph that, the direction is negative pi over 3. And then the reference angle, theta prime, is a positive pi over 3. So on the unit circle, the ordered pair up here for pi over 3, or 60 degrees, is 1/2 square root of 3 over 2. The first value is your cosine of pi over 3, and then the second one is the sine of pi over 3. So to find the cotangent of an angle, the cotangent is your cosine value divided by your sine value. So our angle is down here in quadrant 4. So it's going to have a positive cosine but a negative sine. So we're going to have 1/2 divided by negative square root of 3 over 2. So let's go ahead and keep, change, flip, cancel the 2's, multiply across, and then rationalize it. So the cotangent of negative pi over 3 is exactly negative square root of 3 over 3. One more. The secant of negative 17 pi over 4. So where is negative 17 pi over 4? So we're going to go ahead and find a coterminal angle. So I'm going to take 2 pi, thinking of that as a full revolution, and start undoing it. So you can take negative 17 pi over 4 and add a revolution. So you're going backwards. So we're going to add 8 pi over 4. Negative 17 pi over 4 plus 8 pi over 4 . Oops, that should be a 9 there. Well, we're still too large, so we're going to go ahead and add another revolution. All right, so where does this fall? So we're going to graph that alpha. So negative pi over 4 is right there. Well, its reference angle would be pi over 4. So let's graph our first quadrant reference angle of pi over 4. It has the ordered pair, square root of 2 over 2, square root of 2 over 2. This is going to be the cosine of pi over 4, and this will be the sine of pi over 4. Well, we want the secant. So secant is the reciprocal of the cosine. So this angle for its ordered pair down here is going to be a positive square root of 2 over 2 and then a negative square root of 2 over 2. And what we're going to do is we are going to take this number right here, which is our cosine value, and reciprocate it. So the secant of negative 17 pi over 4 is the reciprocal of that. And now we rationalize it, multiply across, and then cancel those 2's. So the secant of negative 17 pi over 4 exactly is 2.